here we are. All right, so live for the geometry review for 3A. Here we are. So first page. It tells us we're going to be doing translations. And we know what translations are. Translations are slides. So are we going to be adding or subtracting numbers from the x and y? Or are we going to be doing multiplication? Which is it going to be? Add, subtract, or multiply and divide? What are we doing here? What are we doing? Anybody know what I'm talking about? We're going to add and subtract, right? So first, we're going to write down the coordinates for A and A prime. And then we're going to find what we do to them by adding or subtracting. What were you saying, Natalie? No? Are you sure? So A is 2, 5. Let's see, do I have the one from earlier today? Because I can cheat off of that one. I probably do somewhere. I won't cheat. A is 2, 5. B to me looks to be 1, 2, 3, 4, comma 2. And C looks to be 3, 1. I'm sorry, 1, 3. Somebody help me out with A prime. What's A prime? Negative 4, 6. Again, if you disagree with any of my coordinates or Lucas's, can you please tell us before we go too far in the problem? What is B prime, Lucas? Negative 0. Wait, what?
3. Oh, wait, no, negative 2, 3.
Negative 2, 3. B is, or C is, C prime?
Negative 5, 4.
Negative 5, 4. All right, so the next step is you ask yourself, since we're doing translations, that means add or subtract, how do we get from 2 to negative 4? We subtract 6. So x's are minus 6. Check that. Is 4 minus 6 negative 2?
Yeah.
It is. Is 1 minus 6 negative 5?
Yeah.
Then that must be the rule. Let's look at the y values. 5 going to 6. What do we do?
+1.
Plus 1. Check it. 2 to 3?
1. Yeah.
3 to 4?
Yeah.
Wonderful. See what I did there? So the rule is x minus 6, y plus 1. And that's the same for the rest of these. Questions on how to do translation? No, easy peasy. Move on, please. All right, will do. Turn the page. We're going fast. If you need extra reference, watch this video or my first hour's video. Let's look at number 5. All right. What are we doing? What do the directions say, everybody?
Reflection.
Reflection. So we have options for reflection. We're going to multiply or switch the numbers. Remember that? The x's and the y switch. That happens occasionally, not very often. So first, we need to write down the coordinates. Let's look at number 5. Let's write down those coordinates. I'll write down A, B, and C. Somebody else give me A prime, B prime, and C prime. A appears to be negative 2, comma 1, 2, 3, 4, 5, 6, 7. Negative 2, 7. B appears to be 1, 2, 3, 4, 5 to the left. So that's minus 5, and then up 1, 2, 3, 4, 5 as well. C appears to be minus 3 up 2. All right, I'm ready for A prime. Somebody give it to me. What is A prime?
2, 7.
2, 7. Sounds right to me. Mr. Sawyer, keep going. B prime.
5,
5, comma 5. Sounds right. C prime.
3, 2.
3, 2. And you might notice right away that these coordinates are the same except for what? The x is negated. So our rule is negate the x. Is the y changed at all? No, so we keep y the same, so we just write regular y. There's your rule. There is your rule. And of course it is, because what kind of a flip is this? It's a flip that's horizontal, right? And a horizontal flip means negate the x. A horizontal flip is also known as a flip across the y-axis. Cool. Moving on to page 3. Hang on to your butts, kids. Here we go. What are we doing in these set of problems? We're finding the what? What are we doing in this problem?
Rotating.
Rotations. Those are the ones that almost always have a flip of the numbers, but we're not asking you to write those out. All we're asking you to do is to rotate it, okay? So that's when we make our L's, right? Not take an L. You guys are going to have to know how to do this. Don't take an L on this, okay? But we're going to write this out and rotate this figure. So let's look at number 7. Number 7 says 90 degrees counterclockwise. Well, clockwise is this way, right? And counterclockwise is that way. And we're going to go 90 degrees. This is important. Direction matters. Think the opposite way a clock goes. That's what counterclockwise means. So what we do is we draw our L between a point and the origin. Well, my first part of my L goes down here, and my last part goes here. And it connects the origin and the point. So I'm connecting that vertice to the origin with an L, and the L looks like this. If I turn this L 90 degrees clockwise, well, what happens? I hold here, and I turn like this. So now the L is going to face this way. Exactly. So I go 3 this way, because right, it's going down now. That's the blue part right there. I should have colored my fingers for today. And then the red part, instead of going from here up, it's now going to go to the left. So it's going to go to the left 3. 1, 2, 3. And now we're here. Remember, the lines don't change their length. They're the same. And then we plot our point. C prime is going to go there. We repeat this process for the other points. So B is 6 to the left and 3 up. So when we turn that L, it's going to go 6 down and 3 to the left. So 6 down and 3 to the left. So B prime is going to be here. Everybody follow me so far? Yeah, we good? Now you might notice that B and A are both the same distance from the origin horizontally, but A is further vertically. So it's going to be the same distance here, but 3 more in this direction. You got it, Bailey?
Yeah.
Nice. So there we go. There's the triangle. Ta-da! 90-degree rotation. Remember, rotate the vertices. Don't try to rotate the whole thing and eyeball it. It'll goof you. Number 8. Good advice, Preston. Number 8. Try on your own. 180-degree counterclockwise. You'll notice that the direction doesn't matter for a 180-degree turn. Because either way, it'll end up in the same spot. Do it now. Maybe you've already done it. Thinking about that stuff? Dude. Yeah, it's okay. That's all I got. Now that. I should call you no hamster. What? I don't know. I'm trying to. I mean, your nails is different. There it is.
Oh, hey, don't.
We're going, gentlemen. Hey, look, we're doing something today. About time. All right, so let's bring it back in. I hope you mean that with a PH. All right, so we're going to flip this counterclockwise. So we're going to flip it this way 180 degrees. You could have also flipped it that way. It would have ended up in the same spot. I'm going to walk through this real quick, so pay attention. A doesn't have an L between it and the origin, just has a straight line. Well, it's easy to flip that 180, right? We end up here. So A prime is going to be there. Everybody see how that happened?
Yeah.
Cool. Now we're going to do that to B. Well, it's just even further, right?
Sure.
So now B prime is here. Did everybody get A prime and B prime right?
Yes.
C prime's the one that confuses everybody. If you remember this from our quiz, the question is C prime going to go here or here? And if you eyeballed it, you have a chance to make a mistake. If you did it actually the right way, you couldn't make a mistake. Because there's our L. Our L is like this, right? Bum, 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 giant hands. All right, and I flip it 90. That's going to be here. And then I flip it again 180, and it's going to end up like this, right? So where is C going to be? C prime is going to be up. So it's up to.
Well, you did just give us a thumbs up.
I did give you the thumbs up. Bailey, have I mentioned how awesome it is having you in my class lately? Because I'd like to say that. Good. I would like to say it again. All right, so there's C prime. Everybody cool with C prime? Wonderful. Turn the page. Number 4. Page number 4. State and prove in your own words the linear pair theorem. So first, let's draw these angles out. Let's call this angle ABD. Let's do ABC. No, let's do. I don't know how I labeled these. I think I labeled them incorrectly. Yeah, ignore this. Ignore this. Let's do this. This is number 10. Ignore what I wrote. I think this was a typo originally. This is A. This is B. This is C. This is D. Let that be our diagram, okay? state the linear pair theorem and prove it. Who can tell me what linear pair theorem says?
If they're a linear pair, does they're equal
To what?
each other?
No.
Then 90 to 180.
180. If they're a linear pair, then they're 180. So we assume they're a linear pair, right? Let angle ABC and angle CBD be a linear pair. CBD is all the craze now, guys. Be a linear pair. So we let them be a linear pair, because linear pair theorem says if they are, then they equal 180. Or in other words, they're supplementary. Therefore, by definition, again, this is a shorter one than we did originally in our quiz because we can assume more things. By definition, angle ABD, measure of angle ABD, or ABC, I'm sorry, plus the measure of angle CBD equals 180. Why? Because that's what a linear pair is by definition. Therefore, by definition of supplementary, angle ABC and angle CBD are supplementary. And proof. Let me zoom out a little bit. All right, here we go. So, why writing this? We let them be a linear pair, because linear pair theorem says if they're a linear pair, then blank, right? So we say, well, let them be one, right? Let's assume they are. By definition, they must add up to 180, because that's what a linear pair is, right?
What's that like word right there?
By definition of supplementary, like how are you? They are supplementary, because that fits the definition, right? They add up to 180. Remember when this was hard? Remember this was harder, I should say. I should remember when this was harder. There it is. The next one's not so bad. Instead of instead of angle addition postulate, it's segment addition postulate, which means the two little segments add to the big one, right? So as long as you know the setup, it's easy. Let's talk about the next one, number 11. In 5, 4, take a picture if you need it. 3, 2, 1. Natalie's arm hurts, guys. Moment of silence for Natalie's arm. Shout out in the comments to Natalie's arm. So they tell us AB is 2x. You follow? AB is 2x. They tell us that AC, well, the only way to make that is to go from A all the way to C. Is 4x plus 8. And they tell us BC is x plus 3. Does everybody see how I got the setup?
Yep.
Wonderful. So now we need to prove that x is negative 5. We're not going to plug in negative 5 to the equation. I gave you that so you could check your work. So here's what we do. We use by segment addition postulate. Yep, that's how it works. AB plus BC equals AC. Right? The two little segments add up to the big one. That's segment addition postulate. By substitution, we know that AB is 2x, BC is x plus 3, and AC is 4x plus 8. So I substitute their values. And then we just do math. 2x plus x is just 3x. And now we're going to do the thing in real life you would never do in real life, but you would always do in math class. What are we going to do? Get our x's together. I'm going to subtract 3x from both sides to keep it positive because, that's kind of how I roll. Been saying it all year. I'll be here all week. And now I've got my x's all together. I need to get my regular numbers together. What am I going to do next, Bailey?
Subtract.
Bailey, what am I going to do next?
Subtract
What? 8, because I want to get my regular numbers together. And I get negative 5 equals x. Oh, look, it does equal x. There's my proof. Box. How do you feel about the setup? Little guy plus little guy equals big guy. Right? You guys ever seen Nacho Libre? Yeah. Little keys. Little hug. He signs the letter. Two little parts make a big part. That's our postulates for addition. Nacho. Number 12. Translate the given image by vector 6, 8. Number 12. Vector 6, 8. How do we translate an image? We slide it. If we slide it by 6, 8, what am I doing to the x values? If I slide it by 6, 8, what do I do to the x values? I add 6. And what do I do to the y values? I add 8. So I take this a value right here, and I add 6 in the x direction. 1, 2, 3, 4, 5, 6. And then I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. It's that easy. There's a prime. Our vector is this vector, 6, 8. I do this for all of the points. I could take that vector and just do this, and I'd find out where they end up. But I'm just going to count 6, 8, right? 1, 2, 3, 4, 5, 6, up 8. 1, 2, 3, 4, 5, 6, 7, 8. I believe that is correct. Yeah. You'd be surprised how many people got this wrong on the original quiz. 1, 2, 3, 4, 5, or maybe you wouldn't. 6, up 8. 1, 2, 3, 4, 5, 6, 7, ocho. B prime. I'm going to draw on the vectors just for funsies to show you that they're the same vector each time, because that's what a translation is. It is the most fun you're going to have all day. Sorry to spoil you. Yep, that's it. The rest of your day is more boring. It's all downhill from here. Everybody cool with that one? Wonderful. Let's ask the reverse question. 13 gives you the images. I want you to find the vectors. -5, 3. Makes sense to me. Do we start at A or A prime for number 13? We start at A and move to A prime. Don't do the reverse. Common mistake. Moving on. The vector right here is -5 because it's 5 to the left and then 3 up. Let's talk number 6. Page 6. Number 14. Define slope. Somebody tell me what slope is. It's the rise over the run. The easiest definition you have here on this final. Speaking of definitions, those of you who didn't do so well in the last quiz, I would highly suggest you take a look at that Quizlet that has the definitions on it. You had like 2 days in class to do it and a bunch of time, and then you had the retake. If you didn't look at them any of those times, I would look at it now for the centroid, etc., right? All that stuff. Just throwing that out here. y2 minus y1 goes on top. Why do the y's go on top? Because that's what the y's are. They're the rise, right? They go up and down. And the run is how far we went left and right. Remember when we say how far, we mean distance, so distance is subtraction. What do they represent? Bam, that's all I need. Bam. That's perfect.
Bambi.
It's perfect. I remember high school. All right, given the following slopes, they give you these slopes. They want us to write a parallel slope and a perpendicular slope. Guys, this is a two-parter. You guys need to get better at reading directions. So many people miss this on the quiz because they just did one of them. All right, so think about what parallel means. It means we have two lines that never intersect. So what are their slopes? Equal slopes. So if I start out with this slope, what's my parallel slope going to be? The same dumb thing. Parallel means the same. Same slope. So let's look at number 16. What's parallel slope for this guy?
Same thing.
Same thing, 4/3. Oh, wait, I did the same thing you guys do. I didn't read the directions. What else do they need us to find for number 15 and 16? Perpendicular slope. Flip and negate. Flip and negate. So if we flip -1, we get -1. If we negate it, we get +1. Yay!
Oh my gosh, I'm stupid. I messed up.
No, you're not stupid. Guys, check it out. -1 flipped is still -1. And then we negate it, and it's positive. You feel? You dig?
You doing that dig, miss?
I haven't said that non-ironically in like 3 years since I last gigged. You dig? All right.
I'll be diglet.
Perpendicular slope. I need somebody to do number 16 for me. I need a hand, I need a hand, I need a hand. Oh, I need somebody that's... Mr. Stryker. Mr. Stryker, what's the perpendicular slope going to be here? -3/4, because we flip it and negate it. Wonderful. Questions on that? Good. So you have the basics down. Let's talk about 17 through 19. The directions say parallel, perpendicular, or neither. What form are these equations in? Slope form. Y equals mx plus b, right? So we need to look at the slope to determine parallel, perpendicular, or neither. What's the slope for 17? We have two slopes. What's the first one? 2 is the first slope. What's the second slope? Negative a half. What's the slope for number 18? The first one is 1, and the second one is 1. What's the slope for 19? And compare their slopes. You tell me. I'm going to give you about 30 seconds to do them on your own. Parallel, perpendicular, or neither? Remember, parallel means they're the same. Perpendicular means they're flipped and negated. And neither means they're just two random numbers that don't have any relation at all. They intersect for some reason.
I'm so tired.
Parallel lines. Same slope, so much common. Sad. Meanwhile, barely have anything in common. 4 and 5, they'll intersect, guaranteed. At some point, will be a nice intersection. No, not. Life for you. Life. Time's up. Number 17. Are these the same slope? Are these the same? No, so they're not parallel. Are they perpendicular? Yes, perp, because they flip and negate. That was the weirdest perpendicular I've ever drawn. Number 18. Are they the same slope?
Yes.
So they are
Parallel.
parallel. You guys are so smart. Remember them when this was hard? 4 and 5. Are they perpendicular? No, and they're definitely not parallel, so they're neither. You dig? 20. Find the equation of the line from the given graph. Circle the y-intercept. Well, the y-intercept's where you hit the y-axis. Our y-intercept is 4. You dig?
Dig Dug? Dig Dug was great.
The slope is what we get between two nice points. And by nice points, I mean that they hit a square really nicely. This point and this point are on the corners of squares. And how far did I go up? 2. How far did I go over? 1. So my slope is 2 over 1. Cool? Or 2. And it says find the equation. Well, let's write the equation. It's going to be y equals mx plus b. What's our slope? 2. What's our y-intercept? 4. Bam. That's how it's done.
It's easy.
Easy money. Wonderful. We're going to do the same thing now without pictures. So I give you 2 points. It says find the slope, and then it says find the equation. First, find the slope. Who remembers slope formula? It's on the other page. Go do it now. Rise and run. Distance between the y.
Oh, do it?
Rise over, run.
Oh, rise over.
No, but like.
I need to bring more video in this class.
I didn't even touch you.
Championship belt. Oh God! It's Mr. Max music. Can you imagine?
You just walk like
Listen to LL Cool J. Don't call it.
cowboy.
That'll be the song of the day for day 1 of semester.
Bailey.
Hey, the first one. I did one.
Fire. That's how I can be like a sleep guys. That's my resolution. Nice. Nice. Yeah. Well, you guys that should be able to start school this early. Like, we're pretty good. 8:30 is not bad, but should be like 10. Like, imagine we just when we cut out lunch. First, when we just had you guys like. I think all the time, Lucas. Like, how much time would I save if I just didn't eat, shower, sleep, or like anything? Like, I could be so efficient. I could be doing so much stuff. Because you sleep more when you're older and younger. So it'll probably even out to be a little bit more than.
No, it's not.
You know how much time people spend on halfway? That's scary. Look at that statistic. Yeah. That is frightening. Terrifying. Bring it back in. All right, bring it back in, bring it back in, bring it back in.
You did? Where did you?
Who am I waiting on? I'm not waiting on these tables. I'm always waiting on those tables. Maybe I need. Yeah. Bring it back in. Bring it back in. So we have two coordinates. We need to find the slope. Slope formula is rise over the run, the distance between the y's and the x's. Distance is subtraction. Home slice. All right, so we do y2 minus y1. What's 1 minus 2? Negative 1. What's 7 minus 5? 7 minus 5 is 2. So our slope is this. It says then find the equation of the line using the point and the slope. So our equation is going to be, I'm going to write it over here, y equals negative a half x plus b. We don't know what b is, do we? But we can find it. Here's how. You take one of your points. Let's take this one. And you plug it in. You're going to plug in 5 for x, and you're going to plug in 2 for y. Do that now and solve for b. So 5 for x, 2 for y. Whatever it says here, whichever point you choose, Dylan. I chose 5 comma 2, so 5 goes for x, 2 goes for y. And b is the only variable left over, which means we can solve for it. You're going to get fractions, which is going to be just peachy. Now we're here. When you're there, tell me. Estoy aquí.
Well, they don't anyway, right?
Estamos aquí. Are we here?
We're here.
¿Dónde está? All right, so now we need to get our regular numbers together to solve for b. So I'm going to add 5 halves to both sides. Ladies and gentlemen, can I just add 2 and 5 halves right off the bat? Can I add 2 plus 5 halves? No, what do I need? Common denominators, that's what I need. I need common denominators. So, common denominators. All right, so, trademark. Trademark. Guilty as charged. All right, so, we need the 2 over 1 to match the 5 over 2. How many halves are in 2? 4 halves are in 2. So how many halves in total do I have here? 9 halves. So b is 9 halves, so we have y equals negative a half x, plug in b, plus 9 halves. Common denominators.
Common denominator.
Hey, Cameron, what is that?
Later, nerd. See you in the second half.